In this video, I'll demonstrate how to use input and output redirection. When you're working at the Linux command line, sometimes instead of displaying the result of a command to the screen, which is the default, you might rather store it in a file. We can do this with output redirection. For example, if I type ls-R, it will recursively show me all the files and directories from my current position in the file system hierarchy. What I might want to do is take that output and store it in a file, perhaps so I could email it to another administrator. So what I'll do is I'll use the up arrow key to bring up that command again, and at the end of it I'll add a greater than sign. The greater than sign is my output redirection symbol. What I'd like to do is take the output of the ls-R command, and instead of having it displayed on screen, I want it written to a file called filelisting.txt. So we don't get the output on the screen because instead it's been put in the filelisting.txt file. If I cat that file, indeed we can see that output is stored in the file. We can use any valid Linux commands with output redirection. For example, the who command shows me who's logged into the various terminals on this machine. What I might do is take the result of the who command and perhaps put it in a file which I'll call useraudit.txt. And if I were to cat that file, indeed, I can see the results of the who command. In the future, if I want to run the who command again, yet I want to keep the original data in that file, I just want to add to it, I can use the double greater than sign operator. This is the append operator. Because if I just use a single greater than sign, I will be overwriting the current contents of the useraudit.txt file. So what I want to do is append. So I'll use the append operator, and I'll use the useraudit.txt file. And if we cat that useraudit.txt file, we now have two occurrences of the who command stored in that single file. But we can also control input redirection, where data comes from. The default output is the screen unless we redirect it to a file. The default input is the keyboard unless we change that. I'm going to change directory to the sales directory here, where I'll clear the screen and I'll type ls so we can see what's here. There's a file here called 2013 sales. We're going to begin by viewing the contents of it using the cat command. Here we can see some salesperson information with their region, the quarter, and a dollar amount. What I'd like to do is I'd like to use input redirection so I can filter the contents of that file. For example, the grep command in Linux is a line filtering command. So I'm going to type grep-I. I want to do a case insensitive comparison for the name Cody. I'll put that in quotes. And the data that I want to pass into the grep command is going to come from the 2013 sales file. So that's why I've got grep-I in quotes Cody. Then I've got a less than symbol. That's my input redirection. What follows it to the right is the source of the data, which in this case is the 2013 sales file. If I press enter, we can see it took the contents of that file, it filtered it or grepped it for Cody, and only show me the lines that contain Cody. In the same way, I could use any valid Linux command that supports input redirection, such as the sort command. If I were to type sort space less than sign 2013 sales, it will sort the contents of that file. We can see that it's sorted, of course, by region first. It sorts by the leftmost column unless otherwise specified. What's interesting is we can also combine input and output redirection. I'll use the up arrow key to bring up the sort command where we passed it the 2013 sales file. What I'll then do at the end of that command is add the greater than symbol, that's my output redirection, and I want to make a new file called 2013 sales _ sorted.txt. So I'm using the sort command, I'm using input redirection to give it some data from a file, and then I'm taking the sorted result and putting it in a new file using output redirection. So now if I cat my 2013 sales _ sorted file, I can see that information has been sorted and stored in the new file. In this video, we learned how to use input and output redirection. In this video, I'll demonstrate how to use pipes. On the Linux command line, we have the option of passing the result of one command, or pipelining it, to the next command to the right, and we can do this more than once in a single command. For example, here in the sales directory, we've got a file called 2013 sales, so I'll use cat so that we can see the contents in that file. What I'd like to do is I'd like to sort this file by region, which is the leftmost column. And then what I'd like to do is I'd like to remove the line that contains the region. So we're going to do this with piping. Let's begin with one thing at a time. Let's bring up the previous command where we're catting the contents of that file, and let's use our vertical bar. We can shift our backslash key on the keyboard to get that. That's the pipelining symbol. I want to pipe the result of catting that file to the sort command, so we'll start with that. When I press enter, you can see that it's sorted by the leftmost column. So our first entry in the file used to be the region heading followed by north, but now the first entry when we sort it is a blank line, then we've got all, then east, last, and so on. Now what I want to do is I want to remove the line that has all sales figures. So to do that, I'll begin by clearing the screen. I'll use my up arrow key to bring up the appropriate command where we're sorting, and I'm going to pipe again after the sort command. So I'll put in my pipe symbol, and I'm going to use the grep command, which lets me filter lines. I'm going to use -v because what I want to exclude are any lines that contain the word all, beginning with a capital A. If I press enter, we can see that that line has been removed. But I also want to remove the line that says last update. So once again, I'll use the up arrow key to bring up the previous command, and I'll pipe yet again. And I will use grep-v, and this time I want to exclude lines that have the word last. So I'll put that in. Now we can see we've got the correct output, and it's been sorted accordingly by the region. We can use piping with any valid Linux commands. It doesn't have to be catting and sorting and grepping. For example, what I'm going to do is I'm going to type the ifconfig command to show my network interfaces. The first network interface that begins with ENO is the one that we want to work with. So I'll begin by typing ifconfig ENO, and then I'll put in the rest of the name of that interface on this system. That way, I'm only looking at the network configuration info for that single interface. What I'd like to do is extract only the IP address. I don't want to see anything else but the IP address. So we're going to need to pipe the result of the ifconfig command to other Linux commands to make that happen. I'll start by clearing the screen. I'll begin by piping the result of the ifconfig command to grep so that I can include the line that has inet, but then I'll pipe that again to grep where I want to exclude, so grep-v, lines that have inet 6, because I'm not interested in the IP version 6 address, only the IP version 4. When I press enter, we can see it's returned the correct line. Now the problem is I need to remove everything except for the IP address itself, because that's my goal, is to return just the IP. So I'll bring up the previous command and I will pipe yet again. There is a Linux command called tr, which stands for translate. Here, I'm going to pass it the -s switch to squeeze occurrences of spaces, even multiple spaces. So I put quote space quote, and I want to replace it with a full colon. The reason I want to do this is because I need a standard consistent delimiter so that I can extract the specific data I need. So I'll bring up that previous command, and after the translate, I'm going to use the Linux cut command to tell it that I want to cut field number 3, so cut-f3. There's nothing before the first colon, that would be field 1. The word inet would be field 2, and what we want is in field 3, the IP address. But I also have to tell it with the -d switch that the delimiter is a colon. When I press enter, we can see we've extracted just the IPv4 address. So from the Linux command line, we can pipe more than once depending upon what it is that we need to do. In this video, we learned how to use pipes. In this video, I'll demonstrate how to use file name globbing. File name globbing allows us to select files based on some kind of a pattern match. Here in the budgets directory, I've typed ls, and I see a number of budget files for different regions and different years. Now, to properly use file name globbing, ideally you would have some kind of a file naming convention in place where there's at least some thread of consistency in terms of how files are named. So what I want to do for starters is I want to extract files that have 2014 within their name. So my command is ls space asterisk 2014 asterisk. The asterisk is a wildcard that stands for any number of symbols or characters. When I press enter, we can see that it's returned only those file names that have 2014. This time what I'd like to do is extract files that have either 2013 or 2014 in the file name, and I want to do it with a single command. So what I could do then is I could type ls asterisk 201, and in square brackets I'll put 34, I'll close the square bracket, and I'll type another asterisk. When you use square brackets for file name globbing, what you're trying to do is to match one item within the square brackets, not both at the same time. Now, what precedes our square brackets is 201. So in other words, we want to list files that have 2013 in the file name or 2014. Let's see if it works. And of course, when we press enter, we can see from the result that it does in fact work. There are other variations on this. I'm going to use ls again, and in square brackets, I'm going to type east, comma, west, and I'll close the square bracket, and I'll type an asterisk. So we're not limited to using just single characters within the square brackets. Here I'm using words, but they're separated with commas. So if we press enter, we can see that we are listing files now that begin with east and that begin with west, and we've done it in a single command. Now what I want to do is I want to list files within the range of 2013 through to and including 2015 based on the file name. To do that, I'll type ls asterisk. Now, instead of using a square bracket this time, I'm going to use an opening curly brace. Then I'll type 2013 ... 2015. So I'm looking for part of the file name from 2013 through to and including 2015. And I'll go ahead and close the curly bracket. Now, because the year is the last part of the file name, I don't really need an asterisk at the end. So this time I'll just press enter. And if we look carefully at the output, it looks like it's showing us files that have 2013 as part of the file name suffix, 2014, and 2015. I'm going to change directory into another location. I'm going to go to the user files / client codes directory where we've got a number of sample files. We can get a little more complex with our file name globbing depending on what we're trying to extract. Here, for example, I'm going to type ls, and in square brackets, I'll type HC. I'll close the square bracket. I'll start another square bracket, and I'll put A-Z. I'll close that square bracket. Then in another set of square brackets, I'll put 0 to 9, and I will repeat that again. Another set of brackets with 0 to 9. Then I'll follow that with 3 question marks. So what we're doing here is we're looking for files where the name begins with either a capital H or a capital C. Then we're looking for any uppercase letter of the alphabet A through to Z inclusive. Then the third character will be a number from 0 to 9. Same with the fourth character. And then we could have 3 characters of any type at the end. If I press enter, we can see it's extracted the appropriate files. Notably, what it's excluded are files, for example, that begin with the letter K. In this video, we discussed file name globbing. In this demonstration, I'll go over how to switch between shells and between users. Here in the graphical environment, I'm going to go to the Applications menu in the upper left, where under Favorites, I'll then start a terminal shell. I can see based on my command prompt that I'm logged in as user root, but I could verify that by typing who am I. Sometimes we need to switch to a different user, either to run a specific task as that user, or in some cases to test things. Here I'm going to switch user to C Blackwell. SU is the switch user command in Linux. Because I'm logged in as root, it doesn't prompt me for C. Blackwell's password. But the opposite would not be true. That means that if we're logged in as C. Blackwell, and we've just switched to C. Blackwell, if C. Blackwell wanted to switch user to root, now they could type in su space root, or they could just type in su. Root is implied. Because C. Blackwell is a regular user, when they try to su to root, they will be prompted for the password, and they would have to have knowledge of it to successfully switch to root. I'm going to exit out of the root and C. Blackwell session. So I'm back to my original root session. Now we can also use su space dash when switching to a user. The dash means that we want to run startup scripts for that user. So my command is su space dash space C. Blackwell. This time, when I switch to user C. Blackwell, I have the last login date and time, as well as anything that executes from that user's scripts. So there's the etc profile script run by everybody, and there's also a message here from C. Blackwell's bash profile in their home directory. I'm going to type exit to go back to root. And what I'm going to do as root is I'm going to type in echo $shell. The shell variable will tell me which shell I am currently using. Over the years, stemming back from the Unix days, there have been many shells that were used when logging into the environment to issue commands. And they do differ a little bit in terms of command line syntax and how variables are treated and so on. Currently, I'm in a bash shell. And if I were to type set-env, set environment, to display environment variables, it fails. Because this is not a command that is specific to the bash shell. It's designed for the C shell. Now, in many Linux distributions, you will have multiple shells that are installed by default or that you can install. I'm going to type CSH to switch to a C shell. That is a binary program. Now, it doesn't look much different visually. However, the rules of the C shell have now taken effect. For example, if I were to issue the set-env command, this time it works and shows me my environment variables, because that is specific to the C shell and not the bash shell. In this video, we learned how to switch between users and shells. In this video, I'll demonstrate how to switch between TTY consoles in Linux. TTY stands for Teletype Terminal, and it stems from the old Unix mainframe days where we had multiple users connected at the same time to a single Unix host. Each of the users would have their own screen and keyboard. Those were called teletype terminals or TTYs, and most Linux implementations have 7 of them. Here in Red Hat Enterprise Linux, TTY1 is set aside for the graphical environment if your Linux server boots with the graphical environment. But if I press Ctrl-Alt-F2, that'll switch me to TTY2, where I'm being asked to do a login. Here I'll log in as user C. Blackwell, and I'll specify the password. So I've got a completely independent login session here on TTY2 as user C. Blackwell. I'm going to press Ctrl-Alt-F3 to go to TTY3, where I will log in as a different user. In this case, D. Powell. So now I've got root running on TTY1 because that's where the graphical environment runs by default. I've got C. Blackwell on TTY2 and D. Powell on TTY3. Now, other than for testing purposes, we probably wouldn't do this often where we have different users logged into different local TTYs. Realistically, in today's network environment, we might have people connected over the network in different sessions, whether they're graphical or through SSH and so on. I'm going to press Ctrl-Alt-F1 to go back to the GUI, where I will type who. The who command in Linux shows me who's logged in and from where. I can see I have an occurrence for user root connected to :0. :0 is the graphical environment that root is logged into. Whereas the second occurrence for user root says PTS0. That's sudo terminal 0. That, in fact, is this command prompt itself within the GUI. You see, if I go to the Applications menu under Favorites and launch another terminal shell, and if we go back to our original screen and type who again, you'll see I have root listed a third time now on sudo terminal 1. We can also see from the output of the who command that C. Blackwell indeed is logged in through TTY2, and that D Powell is logged in through TTY3. In this video, we learned how to switch between TTY consoles. In this video, I'll demonstrate how to perform searches for files. In Linux, we have a number of different commands that we can use to search for files. Here we're going to use the find command. The find command is recursive by nature, and that means that it will search from your current position in the file system hierarchy through every subdirectory for your search criteria. Now, the larger the file system, the longer it might take to return search results. The first thing I'll do here is I'll type pwd print working directory, and it returns that I'm in the root of the file system. I'm going to search for files using the find command. So I'm going to type find space dash name, and in quotes, I'll look for files that begin with project asterisk. So as long as it begins with the word project, starting with the capital P, there can be any characters after that. Now remember, it's going to recursively search every subdirectory in the root file system. Let's press enter. We can see it returned a number of results that match our search criteria. Now what I'll do is I'll change directory to user files. Here what I want to do is begin searching from this current position in the file system hierarchy. What I want to do is count the number of files from user files down in the hierarchy. To do that, I can use the find command, and in this example, I'll put in dot after find. That means I want to search the current directory. Now, in Red Hat Enterprise Linux, we can omit that parameter. It will assume we're looking from the current subdirectory. But for clarity in this example, I'll put it in. So I've got find space dot space dash type space F. I'm looking for files. I don't want to look for directories or links. I just want files. And what I want to do is print back their names. So I'll use dash print. And I'm going to pipe that result to the word count command, WC, where I'm going to use dash L because I want to count the number of lines. What this will do when I press enter is return a number. Here I've got 42 returned. This is telling me that there are 42 files in and under the /user files directory. I can also search for files based on the user. Now the user, of course, is the owning user of that file. My command is find space dash user space C Blackwell. When I press enter, I get a number of project files returned. If I were to do an ls-l of the projects directory, we can see in fact there are a number of project files that are owned by user C Blackwell. We can also look for files based on date and timestamps. Here what I'll do in the projects folder is I'll use the touch command to create a new file. It'll be an empty file, but I'll create a new one nonetheless. I will call it project11.txt. Now I'm going to type find space dash cmin space dash 3. This will show me any files that were created or modified within the last 3 minutes. If I press enter, the only returned file name is project11.txt, which we had just created. In this video, we learned how to search for files. Video, I'll demonstrate how to perform actions on files that are found. When we use the find command, instead of just displaying the result, the file name, we can perform additional actions. Let's begin by using the find command to find files owned by user C Blackwell, where the name begins with project, and we'll use file globbing here, where it then has to have a numeric value from 0 to 9, followed by another numeric value from 0 to 9, and it must then end with txt. When I press enter, all it returns are the files that were found. It returns the path and the file name. But what if I want to find those files and do something specific with them? For example, maybe I want to do a long listing with ls so that I can see the permissions for those found files, the owner, the date and timestamps that go along with the file, and so on. So what I'm going to do in this case is I'm going to bring up the previous command and I'm going to add to it. At the end of it, I'm going to use -exec to execute some other Linux command, which is going to be, in this case, ls-l. Now, I'm then going to use the open and close curly braces. That's a placeholder for each returned search result. Then I'll type in a space, backslash and a semicolon to terminate the statement. When I press enter, notice that we still have the same two files that were found, but this time it's run ls-l against each one of them. But we're not limited to just using ls-l when we execute commands when we use the find search results. We can do anything we really want. For example, I'll bring up that previous command and I'll backspace back up to exec. Instead of doing an ls, what I might want to do is move the file somewhere. For example, here I'm going to move those files into the root of the file system. Now, I have to make sure after move I've got the open and close curly braces because that means the current placeholder for the search results. And then I've got to put in a space, backslash, and a semicolon to terminate it. When I press enter, the files should have been moved to the root. Let's see if that's true. Let's type ls space front slash capital P asterisk. Indeed, we can see the two files in question, project12.txt and project67.txt, were successfully moved. We might even do something based on size when we search for files. For example, I'm going to type find-type F, so I'm looking for files as opposed to links or directories. I'm going to use -size, where I want to look for files that are more than 500 characters or bytes in size. And what I want to do is I want to run -exec, and perhaps I want to move those. So again, I have to use my curly braces for a placeholder. I'd like to move those to /user files into a directory I've already created called large. Then I'll put a space, backslash, and a semicolon to terminate the statement, and I'll press enter. Now, if I take a look using ls of the contents of the large directory, we can see, in fact, that we've got the files that are larger than 500 bytes copied there. To verify those are the correct files, what we might do is ls-l so we can see the size in addition to the name of those entries. And indeed, if we look at the file size column, we can see the files are correct. In this video, we learned how to perform actions on files that are found. In this video, I'll demonstrate how to use the Linux which and locate commands. The which command, spelled W-H-I-C-H, is used to return the location of a binary program. For example, if I were to type which space ifconfig, it tells me that that binary program exists in /usr, that's Unix System Resources, /sbin. In the same way, I could test another command and say which space who. And it again tells me that that binary executable exists in /usr/bin. So it's just giving me details about Linux commands that I would execute. Now, other than the find command in Linux, we can also search for file system content using the locate command. But locate is different. I'm going to start by typing locate-S to give me statistics. The first thing I see is that locate stores an index of file system entries in /var/lib/mlocate/mlocate.db. So periodically, this database is kept up to date with the update db command. Now, you could run the update db command manually, but it's already scheduled to run as a daily cron job. You can see, based on my current prompt, and if I type pwd for print working directory, that I'm currently in the /etc/cron.daily directory. Cron is a service in Linux that runs recurring scheduled jobs. If I type ls here in the cron daily subdirectory, I can see I've got a script called mlocate. And if I cat that file, what that file is doing in the end is it's running update db to update our locate database with new file system entries that were created that day. So the benefit then of using the locate command is that it is going to search a database. And that database is much quicker than searching the file system. But the downside is that your search results will only be as up to date as when the update command was last run. So for example, to actually use the locate command, we could type locate, and if I'm looking for a specific file like 2013 sales, I could simply type it in. Here, it tells me where that file exists, and this is according to the information in the mlocate.db file. I could also use the locate command with other command line switches like -I to do a case-insensitive search. Here, I want to look for files that have sales within the file name. Notice I don't need to use wildcards with the locate command like I would if I was using find or ls, let's say. I can also type locate -IC space sales. The C means I want to count the number of search results. So it tells me 5. That means there are 5 files that have the word sales in them, case insensitive. In this video, we learned how to use the which and locate commands. In this video, I'll demonstrate how to use Vim to create and edit files. Vim is a command line text editing tool, and it's long been a part of most Unix and Linux installations by default. I'm going to type vim or vim to start the editor. In the middle of the screen, there are some helpful hints, such as the fact that I can type :Q to exit or :help for online help. But what I'm looking to do is I'm looking to add content to this file. Well, the first thing we need to talk about is the fact that when we start the Vim tool, we are put into what's called command mode, where anything we type in is treated as a command to the tool instead of contents within the file. To switch to insert mode so I can begin working with the contents of the file, I will press the insert key on the keyboard, which I've done. In the bottom left, we now see the word insert. So what I want to do is record subnet information for different cities in this file. So I'll begin by typing in a heading of subnet, and I'll press tab a few times, then I'll type city, and I'll press enter, and I'll add one entry for a fictitious subnet, and then what I'll do is type in a city, and after that we'll look at saving the file. Now I'm still in insert mode, which is reflected in the bottom left. If I want to do something such as saving the file, I need to switch over to command mode. I can do this by pressing the escape key on the keyboard. You'll notice that the word insert disappears from the bottom left of the screen when we press escape. This means I'm in command mode, so anything I type in is interpreted as a command. I'm going to start by typing in a full colon. Now you can see the cursor is blinking in the bottom left of the screen, waiting for commands. I'll type in a small w, which means write. Then I'll type in a space, and I'll specify the path and file name that I want to save to. Here I'll type /user, and I'll press tab, because tab completion works here to write out the rest of subdirectory or file names. I'd like to call this file subnets, so I'll include that, and I'll press enter. We now see in the bottom left that our file name subnets and its path /user files are reflected. Now if I want to continue adding content to the file, I have to switch back to insert mode. So again, I would then press insert, and we can see the word insert appears yet again. So at this point, maybe I'll add another subnet here just for good measure. And then I'll save the changes once again. So I'll specify a city here. Now this time what I'm going to do is I'm going to press escape to go to command mode as I did before, but I'm simply going to type in :Q as if I were to quit. Now when I do that, in the bottom left it comes back and tells me that there's been no write since the last change. Then it tells me I can add an exclamation mark to override. If I decide I don't want to keep my edits since my last save, I could type :Q exclamation mark. That means I'd be closing the file without saving new changes. But instead what I'll do is in the bottom left, I've still got my colon, I'm still in command mode, I'll type a lowercase w for write and a lowercase q for quit. So WQ, write and quit. This time when I press enter, it doesn't prompt me for anything and it simply closes out. If I were to use the cat command against that subnets file that we've just created, we can see in fact it saved both lines of information. In this video, we learned how to use Vim to create and edit text files. In this video, I'll demonstrate how to use advanced Vim editor commands. At the command line in Linux, I'll type vim space /user files /subnets. What I'm doing is opening up the existing subnets text file in the Vim editor. I'll go ahead and press enter to open it up. Here we can see in the left column we have a series of subnets, and in the right-hand column, cities to which those subnets apply. The first thing I want to do is remove the line for Orlando from within this file. Let's say we're shutting down that location. Remember that when you start the Vim text editor, by default you're in command mode, and that means anything you type in is interpreted as a command, not as contents within the file. This is good, because my cursor is currently blinking on the Orlando line. To delete the entire line, I would simply tap the D key twice on the keyboard. So I'll press D twice, and in fact we can see the line is removed. At the same time, we can also copy and paste when we're in command mode. My cursor is currently on the Dallas subnet line, and I'd like to make a copy of that and paste it at the bottom. So because my cursor is already on that line that I wish to copy, I can simply tap the Y key twice on the keyboard. So I'll press Y twice, and then I'll press P for paste. Notice it made a copy and pasted it at the very bottom of the file. Now I'd like to make a change to that item, so what I'll do is press Insert to go into insert mode, and that's reflected by the word Insert in the bottom left. I'll just make a change or two to that line, and maybe perhaps instead of for the city of Dallas, we'll put in Austin, and away we go. I'm going to go ahead and press Escape to go to command mode, and I want to save my changes immediately. So I'll type :W. The lowercase w in command mode means write. And I can see in the bottom left, it tells me that it was written to disk. We can also search through a file using the Vim editor. We can even search and replace. What I'm going to do here is I'm going to search for the city name of Halifax and replace it with the city name of Vancouver. To do that, I need to be in command mode. And I know I am because I don't see the word insert in the bottom left. So I don't need to press escape. I'm already in command mode. Instead, I'll type in a full colon. Then I'll type %s because I want to essentially do a substitution. I want to search and replace. Then I'll type in a front slash, and what I'm looking for is the city name of Halifax. So I'll type in Halifax in all lowercase letters, even though in the file Halifax begins with a capital H. Then I'll type /Vancouver. I'll put that with the capital V. Now, as we know, in Linux, everything is case sensitive. What I'm going to do is add a /i to the end of my command string, which means I want to do a case insensitive search for the city name of Halifax. So my command, again in the bottom left, is %s /Halifax /Vancouver /i. When I press enter, we can see in the contents of the file, it found the occurrence of Halifax and replaced it with Vancouver. I'm going to type :WQ to write and quit out of the Vim editor. In this video, we learned how to use advanced Vim editor commands. Video, I'll demonstrate how to create and edit files with Emacs. Emacs is another command line text editor that's long been a part of Unix environments. Here in Red Hat Enterprise Linux, I've had to install the Emacs software package. At the command line, I'll type Emacs, which is spelled EMACS, space /userfiles/subnets. What this will do when I press enter is open the existing subnets text file in the Emacs editor. The screen is split in two with the contents of my file at the top and a help screen at the bottom. To turn off the help screen at the bottom, I'll type Ctrl+X and then I'll press 1. So now our text file takes up the entire window. If I want to begin making changes to the file, such as adding data, I simply move my cursor to that position. In this case, I'll move to the first line and press enter to move everything down, and I simply begin typing in my new information. So at this point, all I'm doing is adding content to an existing file. Now I want to save this file with a different name. Both in the title bar at the top and in the bottom left, I can see the current file name, which is subnets. What I'd like to do is save it with a different file name. To do that, I'll press Ctrl+X followed by Ctrl+W. Now in the bottom left, it's prompting me to write to a file that will be stored under /userfiles. So I'll type in a new file name of subnets2 and I'll press enter. So it tells me in the bottom left that it wrote that file. Sometimes we need to cut, copy, and paste information. For example, to cut a line of data, I position my cursor at the beginning of the line. What I would then do is press Ctrl K. Then I could move my cursor to a new location, and to paste it, I would press Ctrl Y. So we have a number of options available when we want to manipulate the data within a file using the Emacs editor. At this point, I'll press Ctrl X followed by Ctrl C to close and quit. At the bottom, it asks me if I'd like to save the file. I'll press the letter Y for yes. It puts me back at my Linux command prompt, where, if I wanted to, I could use the cat command to display the contents of the subnets2 file, which we can see has our modifications. In this video, we learned how to create and edit files with Emacs. In this video, I'll demonstrate how to use a shell text editor to create and edit a text file. In the Unix and Linux environments, there are many different text editing tools to choose from. One is the Nano tool. At the command line in Red Hat Enterprise Linux, I'll type nano and press enter. Nano is installed with Red Hat Enterprise Linux. When we enter the Nano text editor, at the bottom we have a menu system. What we do is precede any of the letters in the system with the Control key. For example, Control G to get help, Control O to write out changes to disk, Control R to read file, and so on. Let's start with help. We can press Control G to open up a help screen for Nano. Here we can see the key sequences to perform specific tasks. It tells me in the bottom left that I could press Control V to go to the next page of help. And I could continue on until I've exhausted all of the help utility that's available here. I'm going to press Ctrl X for exit. I'm going to open up a file into the current one, and I can do that by pressing Ctrl R. It asks me a file to insert from. Here I'll type /user files, and I can use my tab completion. And the file I want to open is called subnets. So the contents of the file then appear on the screen. There are a number of interesting keystrokes. The first for navigation would be perhaps how to get to the top or bottom of the file. I'm going to press Alt / to go to the first line of the file. If I press Alt /, it goes to the bottom of the file. I can also search through the file. To do that, I would press Ctrl W. I'm going to look for any occurrences of the string Vancouver. So I'll type in Vancouver and I will press enter. It's not a case-sensitive search and it stops where it found the text Vancouver. What I want to do is cut this line and paste it elsewhere. To cut it, I can press Ctrl K. Then perhaps I'll move to the end and I'll paste it by pressing Ctrl U. So now the Vancouver subnet information from this file has been cut and placed at the bottom or the end of the file. I want to make sure I save my changes, so I'll press Ctrl O to write to disk. In the bottom left, it asks me the file name to write to. What I'm going to do is type in /user files /subnets3. I want to save this as a new unique file name. To get out of the Nano editor, I would press Ctrl X for exit. We can then use the cat command at the Linux command prompt to view the contents of the new file we created under /user files, and that file is called subnets3. We can see indeed that Vancouver was moved to the bottom of the file and that change was saved. In this video, we learned how to use other shell text editors to create and edit files. In this demonstration, I'll use the Linux Stream Editor to edit files. In Linux, the Stream Editor comes in the form of a command called sed, which is spelled S-E-D. Sed lets us filter and transform text data, and by default, it sends its results to the screen. Let's begin by typing cat subnets to view the contents of this sample file. In the left-hand column, we see some IP subnets, and in the right-hand column, we see the city to which each of those applies. Well, with the sed command, we can filter what we're viewing or delete content or search and replace content. Let's begin by printing every second line from this file. So I'll type in sed space -n. The -n suppresses the automatic printing of every line in the file, which will remove duplicates. After the -n, I'll type in a space, and in single quotes, I'll type 1 tilde 2 p. What this means is I want to start at line 1 in the file and print every second line. But I've not yet told it where to get the data from, so at the end of this command, I'll type space subnets, because I want to base this on the contents of the subnets sample file. When I press enter, we can see from the output that it's only printing every second line, starting with the first header line. Now, not only are we limited to displaying this on the screen, but we can also use output redirection to store the output in another file. I'll use the up arrow key to bring up that previous command, and I'll add the output redirection symbol at the end of the command. That's a greater than sign. And I want to dump this into a file called every_other, and that file will be in the current directory. So nothing showed up on the screen because instead of the default output being sent to the screen, we've redirected it to a file called every_other. Why don't we use the cat command and take a look at that file to make sure it contains what we think it does? And it does. It contains, starting with line 1, every second line from the subnets file. In the next example, we'll use the sed command to remove or delete every second line from the output. So I'll type sed space, and in single quotes, I'll type 1 tilde 2 d. Last time we used a lowercase p for print. This time we're using a lowercase d for delete. Then I'll type in a space, and my source for data is the subnets file. When I press enter, we can see, in fact, it removed every second line. Let's just use the cat command to display the contents of the subnets file so we can see the original. And if you compare that against our output, indeed, it has removed every second line. But we can also use the sed command for substitutions, or search and replace. What I'll do is I'll type sed space, and in this case, in my single quotes, I'll begin with a lowercase s, which means substitute, followed by a front slash, followed by the word Vancouver, that's what I'm searching for, followed by another front slash and the word Montreal. So I want to replace Vancouver with Montreal. I'll add a front slash lowercase g and close my single quote. The /g at the end means that I want to change every instance of Vancouver to Montreal. So let's say that there might be more than one occurrence of the word Vancouver on the same line. Without the /g, it would only change the first occurrence on the line. So I want to change them all. And then at the end, I'll add the subnets file name. When I press enter, we can see from the output that the Vancouver line has been replaced with the word Montreal. In the next example, what I'll do is use the sed command to filter out the IP subnet addresses in the left-hand column. Let's say all I'm interested in is the number of bits in the subnet mask, so for example, /16 or /24, along with the city name. So I want to strip out the rest of the IP subnet starting from the left. This is easy using the sed command. My command will be sed space, and in single quotes I'll start with a lowercase s because I am going to substitute. What I'm going to do here is type s front slash. I'll shift my 6 key to get the caret symbol *0. What this means is I want to start at the beginning of the line. That's what the caret symbol means. And then I want to take a look at any number of characters, so ** up to the zeros. Then what I want to do is replace it with nothing, so I'll type // and I'll close my single quote. And then I'll type in the name of the file on which I want this to occur, which is the subnets file. When we press enter, notice in our output that we no longer see the IP subnet. It's removed everything up to and including the last 0 and replaced it with a blank. So all we see are the number of bits in the subnet mask, like /16 and so on, along with the city names. In this video, we learned how to use the Linux Stream Editor to edit files.